Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Starting material is 4-nitrotoluene, methyl at C1, number 2 at C4. Moving on to the next step. Cl2Cl3 is electrophilic aromatic chlorination. The methyl group, ortho-para director, and number 2 group, meta-director, both influence substitution. The methyl is at C1 and number 2 at C4. Positions ortho to methyl are C2 and C6, para to methyl is C4, blocked by number 2. The number 2 group directs meta to itself, which corresponds to C1 and C7, but on a desubstituted ring, the combined directing effects place Cl at C2, ortho to CH3, meta to number 2. This gives compound A is equal to 2-chloro-4-nitrotoluene. Moving on to the next step. FeHCl then now H reduces number 2 to NH2 via aniline intermediate, then free base. So B is equal to 2-chloro-4-aminotoluene, i.e. 4-amino-2-chlorotoluene. And for the final step, B and C share the same intermediate line, so C is equal to B is equal to 4-amino-2-chlorotoluene. Br to Fe-Br3 bromination of C, 4-amino-2-chlorotoluene. The NH2 group is a strong ortho-para director. The ring has methyl at C1 close at C2 NH2 at C4. Positions available ortho-para to NH2, C3, ortho to NH2 at C4, C5, ortho to NH2 and C1, para, blocked by CH3. C3 is between Cl, C2 and NH2, C4, somewhat hindered. C5 is ortho to NH2 at C4 and available. So Br enters at C5. Product D is equal to 4-amino-5-bromo-2-chlorotoluene. Now H treatment of D. Here now H does not change the structure significantly for an aniline. E is equal to D is equal to 4-amino-5-bromo-2-chlorotoluene, or possibly used for deprotonation in next step. H2 so 4 nano to H2O at low temperature is equal to diazotization. The NH2 is converted to diazonium salt. F is equal to 4-diazonium, 5-bromo-2-chlorotoluene salt. H3PO to H2O is equal to hypophosphorus acid, which replaces the diazonium group N2+, with H, reductive removal. So the NH2N2+ at C4 is replaced by H. Final product G is equal to 2-chloro-5-bromotoluene, toluene with Cl at C2 and Br at C5, i.e. methyl at C1 close at C2 Br at C5. The structure shown is a benzene ring with methyl at top, C1, Cl at C2, ortho to methyl, and Br at C5, para to Cl, meta to methyl. This matches to chloro-5-bromotoluene is equal to the product G. Options B has Br ortho to methyl and Cl para, wrong regiochemistry. Options C and D show ketone substituents which are not part of this reaction sequence. Therefore, the correct answer is A. Therefore, the correct answer is option A.